All right, guys, welcome to another discussion with Hex Technology. Today we're going to talk about oversizing of blue bolts. PTFE studs or blue bolts have to be oversized in order to fit the coatings on there. Well, I didn't know this when I first started working with them. I always noticed how easy they are to run off and run on. And I always thought, I was told that, it's because the PTFE acts as a lubricant. So here was my little awakening that I had on how these PTFE bolts are made. The first thing I did was I said, okay, let's see how great DoxSteel bolts. This was given to us by Carlos Girault with DoxSteel. And he said, okay, we're going to put multiple flanges in Cooling Drift Tower in El Dorado, Kansas over the winter and just let it collect all sorts of corrosion on it, right? So we stuck these flanges in there. We torqued them up with DoxSteel bolts, the ones on the left, and then you see on the right, we did PTFE studs. And so when we were using these, we were looking at breakout torque is what I was looking at just to see how it would affect. And with DoxSteel, we had a higher breakout torque than with the PTFE. And I said, if you're coating so much better, how come it's so easy to break out with PTFE? Didn't make sense. I was like, well, maybe this whole, it's a lubricant and right acts as a lubricant. The PTFE is better. And what they did is they have DoxSteel had a nickel cobalt electroplating on it, kind of like what you do with your car with paint. They do it with studs. And so they had this really super technology, it seemed like, but a higher breakout torque. And I asked Carlos to explain to me, why is that? And he said, man, first let's talk about oversizing. And then how do you eliminate it? I'm not going to get into that. That was further down in the presentation because it has to deal with studs and standards that I'm not as familiar with. But I'll tell you the part that I did get familiar with, and that is, what is oversizing the nut? Does that really happen? Yes, it does. So these two on here, the two pictures you're seeing are same magnification, DoxSteel versus the blue bolts. And if you look, the DoxSteel, it's got the electric plating on it over here. Real tight fit all the way around, right? Pretty good. You look at this guy on the PTFE and you see how this guy is sheared right there, right? It doesn't come down and engage completely. And this guy is sheared too. And you've got this PTFE zinc lining that's kind of popping off over here and over here. So I didn't realize there was this much oversizing. And I said, okay, is there any way to take an x-ray of the stud? And they figured out a way to x-ray the studs, right? And they said your load capacity for regular studs and nuts is going to be higher than on PTFE coated studs. And they said, here's what it looks like if you were to take an x-ray. These guys were torqued down to, I believe, like 250 foot-pounds. So it does have some load on them. And you can see this is just a regular stud, and there's good, pretty decent engagement all the way through. However, and this one right here, sorry, this one was their DoxSteel one, right? Same thing, good engagement all the way through. However, when you look at the oversize, look at that oversize. And they were saying this is 50% more than what like the tolerance is. So you really don't have that much contact surface area on each one of these. Now, what's really awkward on this one is if you look at the bar on the right, that's a little bit tighter than the one on the left. The one on the left looks really loose. And so I said, why do you see that? And so what they did is they put on these spacers. That's what you're going to see here is spacers. They put these two nuts on. They said, look, if you don't oversize, you've got a pretty good production matrix, right? You're used to doing it this way. All your tools are sharpened this way, so on and so forth. They said, however, when you get to the oversizing, right? This is the nickel cobalt, no oversizing. But you can get this like 24% to 6% difference. So that's how much oversizing, right? How much material they took off in order to make it work. And what we found is the oversizing of the nut directly affects the K factor. We've got another study on K factors on our website, if you go look at it, to see with 6 different manufacturers how a K factor for non-lubricated PTFE studs goes from like a 0.11 to a 0.28, which is Holy cow, crazy for a K factor. And part of the reason we believe is the fact that this over tapping of the nut isn't as consistent as we would think, right? It's another variable that we're putting in. So oversizing the nuts is how they put the PTFE coating on, so where it doesn't just scrape off. So we thought this was pretty impressive, right? This is the total area of the stud. Total area of the stud goes down. And it was just amazing to us to see what this looked like. Here's another one, right? No oversize. And then you start looking at the difference right here. It's just a lot less contact area in there. So we used to think it was because of the coating, but really we're finding that it's the over tapping of the nut. So we have to say thank you to Carlos and his team at DoxSteel. And his saying is thinking inside the nut. I hope you enjoyed this quick presentation. If you guys need any more info on this, if you'd like to discuss it, we definitely have some articles on our website, or you can contact us at info@hextechnology.com. Thanks so much. Have a good day.